This 12-minute video is about an engagement that Computer Task Group's logistics practice performed for Whirlpool Corporation, the global appliance manufacturer. The system was designed, implemented, commissioned, and put into place in 2 of their major distribution facilities and is being rolled out across the country. The first site was their factory site in Findlay, Ohio, where they manufacture the new generation dishwashers. And that site is about 600,000 square feet, works 2 shifts, 6 days a week. And the second site is in St. Louis, Missouri. It's their Quality Express site. There is no factory located there. All the product is trucked in and trucked out. Orders are taken in one day. They are shipped the same day and delivered to customers the next day. It's a brand new facility, over 750,000 square feet. The system involves radio frequency terminals on all the lift trucks and in other places within the facility. We interface to all their existing equipment, including a lot of old conveyors coming from manufacturing, and had to integrate that with a 24-hour switchover. We interface to the guard shack, to the spotters in the yard who actually move the trailers in and out of the facility. This is the main aisle in one of the facilities. You can see they're quite large, lots of different product at different sizes, stacked to the ceiling. Space management is an issue when things get tight in the facility. Here's the conveyor coming in overhead from manufacturing. We actually track the product, scan the barcode, divert it down lanes. Here's the scanner. And then direct it with lift trucks to actually pick up the product from stackers. Stackers will be showing up in a second. Here are the stackers. We actually direct the lift trucks. They pick up the product and either cross-dock it directly out to outbound loads or put it away in the facility. All the assignments is computer directed with human feedback to correct errors. Here's a load ready to ship at the door. As you can see, there's lots of onesie, twosie different models shipped just in time to customers. Loads are labeled and scanned as appropriate. This is in our integration facility. This is some of the RF gear. You can see there's different size terminals for different functions. The entire system is staged in our lab so that we can do full integration testing before we go in the field, do high performance stress testing, error checking. There's the conveyor gear in the background, a simulator, number of PS2s running OS2, modems to hook up to the Whirlpool host, actually the entire complement of machines. Here are database backup machines that shadow all the data in case there is a hardware failure. Here's the super base station, and here are the radios. In the field, the system is running with 2 base stations in case there is a hardware failure. There's an A-B switch to switch over to the second base station so they can run 24 hours a day without stopping. The handhelds are used by spotters and scanners and inventory control auditors. All the other radio gear is mounted onto forklifts. This is the conveyor gear that we wired up to replace their existing mini computer that was running the conveyors. We replaced it with 1 PS2 and some circuitry to handle all the scanning from manufacturing and all the conveyor controls. We actually built a simulator so we could fire inputs as if we were hooked to the conveyor, so we could fully test it in our lab before going in the field. This is a bridge box so that we can actually dial into any Whirlpool facility live and upload or download data and observe the system while it's in the field. Now here's the office equipment, people that run the system from back at the office. We'll run through a couple screens here to get a quick look and feel of the system. It's Presentation Manager, which is mouse-based, very user-friendly. This is the main menu. We'll first go to some control menus, show you how work is activated with a double click of the mouse. You just select the work to activate and fire it up. You can see all the details of the job, including some overrides you might want to activate. This next screen is the big board, which shows in real time the status of all the active work. It's color-coded to set off warnings if work is being late. Down at the bottom, you can see the number of people logged in doing different functions at all times. You can see the actual work flow to the floor in terms of orders and units, high, normal, and low priority. You can see the percent complete on every single job and the status it's in. You can zoom in for details, get the specifics in real time as the order is being processed, and you can even change priority so that you can apply more or less resources to a job while it's being picked. There are quite a number of status menus, everything from trailers, orders, the amount of work, the amount of space in the warehouse. We'll just quickly highlight a few. Let's look at inventory by model. A lot of different ways you can look it up. We'll look up a specific model. Notice how responsive the system is. It's quite fast. We'll hit it now. Went through the entire warehouse and found all the locations that have that specific model in them. You can see the quantity in each location as well as how many could fit. Here's a mixed location with multiple SKUs. Here's a location that's mixed and a locked location. Here's a locked location. This shows information about all the models, the velocity, the name of the model. Here are the quantities in the warehouse of all the SKUs. Some of them are on QC hold, some of them might be damaged. Here we see the shipment history by month. Now we'll look at inventory by specific location. We could look up a specific location or an aisle or a zone or empty locations. We'll look up all the locations in a specific zone. Goes through the entire building, finds all the locations. It's very easy to see which locations are mixed, which locations are empty, and all the rest actually have product in them. And of course you can zoom in for details and get all the specifics of what's in that location. Now we'll look at a configuration screen. This warehouse mode screen lets you change the algorithms of how the system is running in the background. You can, at a touch of a switch between least travel mode, which emphasizes productivity, or space utilization mode, which emphasizes space. Plus you can turn on or off various options for how the picking and put away rules are implemented. These changes go into effect instantly and are seen then on the RF by the people who are doing the work. They're actually even unaware of the changes going on in the background. You can set different times for those color warnings on the big board. You can change the number of people actively working an order. You can set different things having to do with freshness or expiration dates, change modes of the system. It's simple to use, but a very powerful screen. Now we'll look at some of the system features running in the background. This is the system health screen that shows you all the processors that are running the system. It is a distributed system running across multiple PS2s running OS2. On the left you see the processors and their status. As you can see, they're all up in green, so they're all running with all the, and these are all the processes on the right that are running on those boxes. So we can zoom in to see the specifics of what's on each individual PS2. There's the inventory program running on a certain box. It's currently running on that box. It's primed to run on that box, and it's configured for a backup in case that box is unavailable or has a power failure or something. Okay, here we're going to simulate a failure by crashing a software program on purpose. This could be from hardware or from software, bad memory, or whatever. And the LAN will detect that error remotely and alarm it. I'm on another box now, intentionally crashing a program. The cross goes red. Alarm messages happens. You get an alarm window. If we zoom into the red cross, we can see the box has detected the failure and is reinitializing the process and bringing it back up and running again and hooking it back in with all the connections to the other programs in the LAN. It's restarting. It's now running. The system was written in C using OS/2 and TechLogic's radio gear. The host communications was LU6.2. Here are the people who implemented the system and installed it for Whirlpool.